All right, hi everybody. In today's video, we're gonna be using the linked list that we made. We're gonna be getting rid of all this testing code because we don't need it anymore because everything is fine. And then we're gonna be moving on to actually building what a command is. So again, we're using the command pattern. I'll just show it right now so we can all take a look at it, right? I don't know if they show UML. But basically what it's doing is that it's allowing you to execute things. I don't think we're actually going to use that. I think we're just going to use it as like a data structure. And we're going to pass it over into the Sokoban class, which will then execute the command or undo the command. Does it mention undos in here? Kind of curious. Yeah, and it does. Cool. So that's what we're going to be doing. So the command is actually pretty simple. We could do, let me actually go to game header file or C++, where you can see this is basically what the command is going to be. It's just going to be a point. Now, how we're actually going to get into, well, when I think about it like that, I don't think we even need a command, right? I think we can literally just use this point, and then we can figure out how to do undo later. So that's kind of nice. We can remove some code. Okay, cool. So in our game header file, I'm going to add a pooled linked list of type point, and I'm going to name it commands. Pretty simple. And then that's gone. Don't save that. I think I saved it. Yeah, I did. Oops. Cool. And so what I'm going to do is I'm going to check our pooled linked list to see if we need to do anything for the constructor. And the answer is no. So we are good on that. So now what I'm going to do is I'm going to say commands dot pushback, right? 0, -1. And actually I'm going to do, what's interesting here is either we can push to the front or to the back. So to put it visually like this, right? Either we can push from the front, so every time we push it here, we move everything over if it was an array, but because it's a linked list, right? There's no actual, like, we have to move things over, which is kind of nice. So we could push to the front or we could push to the back. Because we have like our tail reference, honestly, either direction is totally fine. Because I started with that, I'm just gonna do it that way. And then I can do commands dot tail. Can I get to commands dot, is it, oh, it's, I didn't do that. It's just back, which is way easier for me personally. And then it's dot data. And then it's this data. And that's it now. So I almost wish we could just, what I'm trying to think about is if there would be a way for us to check if there was a change and then we could just remove the code a little bit, but this is fine. So I'm just gonna do this, delete that, delete that, delete that. Now I'm gonna take these, I kind of wish I kept those just as a check. Do this, now we do this. So this is for right, so this 0, and then this is for down, and so this is 0, 1. You can see I have a little typo here. Right, this is gonna be left, so it's -1, 0, and that's that. Okay, so if we make it now, hopefully no errors. Sokoban, play, we'll just do this. And we're creating a bunch of data on the linked list, and we could actually visualize that real quick, fun enough. Let me go to render, right? We can go to move 0, 0, right? And we can do print W, and it would be like %I, what is a point again? I think it's integers, yeah. And I think it's %I. I always mess these up. And then it's, so what we need, by the way, is if ll, if commands dot size is greater than 0, right? Then what we can do is this, 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 and then we can do const point p is equal to commands dot back. I keep doing the tail thing, data. Okay, cool. And then this is p dot x and p dot y. So now if we make it, let's see what we get. So no errors, and then when I move, something's gonna show up right here. 1, 0, negative 1, 0. Right, and then if we also want, we can also add in one more variable. I think it's like %zu for some reason. Again, this is not where I thrive. Let's see. So we do that, we play. And yeah, you can see that's working, and you can see as we keep going, the moves, actually the commands actually should be equal to the moves right now because we don't have undo. But there it is. So there's our command pattern working with our linked list. I'm gonna actually keep this around for right now, but I'm going to add, to do, remove. Okay. So there is our command pattern. Kind of started to go where we are storing the commands, and now what we want to do is allow the user to undo their commands. So the first thing I'm going to do while I'm still thinking is I'm going to go into instructions. I'm going to do this, u to undo. Cool, cool. Now I need to figure out what is wrong, and that is because the instruction size increased by 1. So now if I make it, we'll check to make sure our instruction screen is still working. And u to undo, looks good to me. This is actually, I almost feel like we should do this, this, make it. Yeah, I think that's a little bit better. Okay. So now we have our instruction screen. So now what I'm going to do is I'm going to go to Sokoban. I'm not actually going to do anything yet, but I'm going to, where's the update function? So it's right there, right? I'm also going to add void Sokoban, and this time it's going to be undo. And it's going to use the point again. So we're going to do this, this, and there's that. So we're not actually going to do anything yet. All we're going to do instead is we're going to change commands. We're going to actually do move 0, it's 1, it's y index, that's right. So now I'm going to take this, 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 and we're going to just make sure we'll do this, moves, and we just want u. And I guess I have some bad memory. Is it in the application state? Yeah, it's in the application state. We definitely overuse the application state, right? Like there's no reason this can't just be in the game, but I also know why I was doing it, just for convenience. But anywho, so we have this, and the other thing to do is when the player restarts, we also are going to want to do some stuff with the commands, mainly just clear them because we're no longer using them. And same thing when the player quits, where if the player quits, there's just no reason that we should actually have to handle that. Now let's go into here, and we're going to do two cases, case u, right? We'll break it. And then what we want to do is we want to do app state first moves equals app state. I'm going to do it like this. And then we'll do std : max. I always am confused, like should I do like std, std, standard, something like that? Okay, so let's look at this where we're doing the number of moves, which is size t, which is fine when we're doing it like this. But once we get to, I wonder if there's just some trick that I don't know. There almost certainly is. But we're just going to change these to ints. And then that will fix that. And then we won't, basically this makes it so we don't actually have to worry about the case of where it could go to negative. Because if it goes to negative with an unsigned, it could wrap around and then become too much. And then it just becomes a whole nightmare to deal with. So now we just don't have to deal with that. Now we do have to go to the level data, which I think is in application state again. And it's right there, and we just make it integer, and our life is a little bit easier regardless. Let's see if there's any compiler errors. Let's go into the save state to make sure we didn't break anything real quick. So I'm gonna make this like 200. We'll run Sokoban, we'll play. Oh yeah, you could see like 200 is showing up still. Boom, and we're back to 6. So everything appears to be working. Our save file is still working. If we rerun, that's still working. So I think that update is okay. And now we can get back to doing our undo. So this is where we're making it so that the moves go just down. I actually didn't show that, so let's go back real quick so we can see that. So I'm here, you, and then it stops, so it doesn't go into the negatives. So that's perfect. Perfect is a strong word, but that's working. So we can keep going on this, which is now what we want to do is, I almost wish we'd implemented a pop function. So rather than remove a pop, which we can do. So let me actually do that where we're going to say Sokoban, if I can spell, undo. We're going to give it app state. Is it app state? Yeah. Game state. Yeah, I definitely went overboard on using the app state, but that's okay. So then the other thing we want to use now that we have our app state is we want to use our commands. And then what we want to do is we want to, instead of, so we have these like remove back, remove front. What I actually want to do is I want to call a pop back function. So now let me go into the linked list. Let me go to, I'm going to return here, and it's going to be pop back, right? And this is the exact same code, but we're actually going to keep this temp, right? So what we're going to do is we're going to have t data is equal to back data. Then we return data. And let me implement the other version of this, pop front. And again, this is the exact same code, right? But we have to, let me double check this. Yeah, this is fine. So now I say t data is equal to front data, return data. So now we have popping. We're not actually going to test these. Well, let's test them. So let's go into our main file, and we'll put in like a pooled linked list. Type int ll. Then we need to make sure we're returning so we can actually see stuff. L.push, we'll do like for int I is equal to 0, I less than 10, plus plus I. We'll do ll.push. Let's do push front, and then we'll do I so we can see that. And then what we'll do is a print. So we'll get a pool node, type int star temp is equal to ll.front, while temp does not equal null pointer, right? Now we're just looping through our list, our linked list, as standard cout temp data and L. Temp is equal to temp next. Now we're looping through it. We're just going to test this part first. We'll make it. I messed up. Where did I mess up? Pooled linked list. If this is equal to null pointer. Oh, there's no return value if. So in popback, we actually should do like, I think there's like a static assert. Yeah. Static assert back equals null pointer. Does not equal null pointer. Something like that. I don't know. It could be a better message. So let's do that. And then we'll do this. Pop front. And that seems fine to me. It could still be back, by the way, but just for this, we'll do it like this. Have a little typo there. Now we have a problem with null pointer, or with this. Okay, so can we just do assert? I don't even know. Let's try this. No. Okay, so let me just see C++ assert. I know we were using like a C version of it before, but this is the static assert. Let me just do this, because frankly, I don't even really care about these error messages. I'm assuming I still have an error. Oh, all caps works. Hashtag include. What am I needing to include for this? Just C assert, sure. If I make that, that runs. Now if I run it, now we're testing. That looks good to me. So let's go back to main. And what we're gonna do this time, we're gonna do it, so we're gonna actually get rid of this. So while ll.front does not equal null pointer, cout ll.pop front. Looks good to me. Let's run it and hope we don't get an infinite loop. And we don't, we get a seg fault, which is a little bit weird. But we don't get a seg fault until we get to the very end. And the reason why I'm a little bit confused about why we get a seg fault, right, is, where is it? So we don't need that, we just need this. Pop front. Right, this should be catching the whole null pointer seg fault kind of thing. So now we'll just include it ourselves, I guess. Let's make it and run it. Oh, so there's another problem. So we'll make the operator precedence more clear for the compiler. Let's see this. Okay, so that's just very hard to read. So let me, is null. So we'll do this. So we get 0, 0, 0. Then we get to here. And then we get our null pointer thing. So this is where like we're not getting a, so let's just double check the logic basically. So in this case, we've said front is not a null pointer. Looks good to me. We get the front. Then what we do is we say front is equal to front next, which makes sense, right? And I guess what's happening, is like front previous is equal to null pointer. That makes sense because we remove the previous and then we just keep going. But at a certain point, we should be getting to 0, right? Where like, if we did like, let me just double check to make sure it's not something kind of crazy. Yeah, no, it's regardless. Okay, so I'm just gonna keep these as, I'm just gonna keep this as a to do. We need to fix this case for our linked list because that's worth fixing. But I don't think it's worth fixing right now because it's not really the point of the video, but we'll come back and do it in the next video. In the meantime, what we're gonna do is we're actually gonna get to calling undo. So in Sokoban undo, let's actually get into here. We actually have a pretty sizable-ish challenge to think about. And I'm actually seeing we're at 21 minutes for the video, so we may not even get to this. So I think what we're gonna do is just kind of talk about what we need to think about, and we'll start with the easy part, which is that if we have basically this point, we need to, this is the command, we need to create the opposite of it. So what we can do is p.x, oh no, we need to actually name these, oops, 1 second. State p, right? Now we do our new point, undo p, we'll just do undo is equal to this, and I actually kind of like the dot notation for this, dot x is equal to negative p dot x. Dot y is equal to negative p dot y. And why we're doing this, I'm going to show you in just a second. So now what we can do, yeah, I think we can actually just do this. We can do Sokoban update. Did I spell that right? Yeah, I did. That looks fine. And then what we can give it is state undo. And then this is missing a semicolon, so that's it. So if we just do this, play, play. So now I've moved twice, and we get a seg fault, which we expected because of that other mistake back there that we were testing for. So let me clear this. I actually just have to exit it. So Sokoban, play, but you can see the basics of it are working. But the problem is if I press U now, the block doesn't go back. So those are our two problems. The first problem is that right now the block isn't affected by undo. And the second problem is that if I press U one more time now, as you can see like right here, what's gonna happen is we're gonna seg fault because something is wrong with our pop back / pop front function logic. We can fix it, we will fix it. What it's gonna boil down to is basically front isn't being set to a null pointer when the size is 0. We could fix it with something like if size equals 1 as a special case, right? And then what we would do is, well, first we need to return temp, and then we would do like t temp is equal to front data, and then we would just call delete front equals null pointer, something like this. And I think that would actually just fix it. But personally, so let me just do this. Oh, didn't work. Shame. But this is one way how we could fix it. Oh, is that actually right? Let me run it one more time just to make sure. So we do this, U, and it does just break. Okay. So even this isn't working. So I'm maybe even wrong about how this is supposed to be working. Maybe our assert isn't being called like I think it should be being called. But ideally, we shouldn't even have, I guess like we'll have to have some case where if the size is equal to 0, so like in here, basically if commands dot size is greater than 0, yeah, just greater than 0, we'll have to do it like this, and then we'll do this, and that works. Then we do that. Oops. Yeah. So we still need to handle the case where when we get to 0, something's wrong. But that's for next one. This needed to be in here anyways. So for the next video, just to wrap it all up, we're going to fix the problem with our linked list in terms of how we're doing pop back. And then what we're going to do is we're going to go into the undo function we made right here. And we're going to make it work for not just the player, but also for the, that should be a constant. We're going to make it also work for blocks. So if the player moved a block right, it will move it left. If the player moved a block up, it'll move it down, etc. That will require a bit more logic. It may take 2 videos, hopefully not. But yeah, I hope you enjoyed this one, and I'll see you in the next one. Bye.